Welcome back to the channel, everyone. In this video, we are diving into one of the most powerful machine learning algorithm out there, the support vector machine, or called SVM. This algorithm is widely used for classification tasks, and we are going to break it down step by step. So what exactly is support vector machine? Well, imagine you are trying to classify data points into two categories. SVM helps us draw the optimal boundary called the hyperplane. The best separate the two classes. But it's not just about drawing any lines. It's about drawing the line that maximize the margin between the two classes. And let's see how this works with some visuals and code. Imagine you have a two classes of a data points, and as shown in here, the SVM try to find the line or the hyperplane that best divide these two set of points. But what's special about SVM is that it chooses the hyperplane that maximize the margin. That is the distance between the nearest data point of both classes, and these nearest points are called support vector. So these are called the support vectors. Here's an important concept. The width of the margin is the key. A width, a wider margin generally lead to better generalization in our model. And so we want to find the hyperplane that maximizes this margin. But what happens if the data isn't perfectly separable? That's where the SVM gets more interesting. So SVM can handle different types of data, and the three main cases. First one is the linear separable data. The two classes can be separated by a straight line or a hyperplane in the higher dimension. Second, the linearly inseparable data. The two classes cannot be separated by a straight line, but we can still use SVM by introducing a soft margin. And the third one is the nonlinear data. When the data is nonlinear, we use something called kernel trick to transform the data into higher dimensional space where it becomes linearly separable. So as you can see, SVM is quite flexible, right? It's able to adapt whether the data is perfectly separable or not. And when the data is non-linear, we use kernel to map it to the higher dimension where linear boundaries can be found. So at the heart of the SVM is optimization. We want to maximize the margin between the two classes while keeping the classification boundary as accurate as possible. So mathematically, we are solving a constraint optimization problem. And let's look at the basic SVM object. So we want to maximize the margin M. So in this formula, the margin M, which is defined as the distance between the hyperplane and the closest data point. And the formula for is M equals to 2 divided by the normal vector to the hyperplane. The key idea is that we are maximizing the margin while making sure that each data point is correctly classified. Let's jump into some codes and implement support vector machine from scratch using the popular Python library Scikit-learn. First, let's import some libraries. So I will just import this. So here we are using NumPy for numerical computations, Matplotlib is for visualizing the result, and Scikit-learn for SVM implementation. Next, let's load some data set that we can use to demonstrate the SVM. So let me run this cell. So here we are using the famous iris dataset, but limiting ourselves to the first two features to make it it's a 2D problem. This will make visualization easier. And now let's train our SVM model. So I'm just simply calling the SVM model here, and we are creating with the linear kernel and then training it using the data. It's that simple, right? Now comes the first part, visualizing the decision boundary created by the SVM, right? So let me run the plotting result as well. So in this code, we are getting a mesh grid to cover the entire feature space and then use the trained SVM model to predict the class for each point in the grid. So this is the visualization, and we then plot the decision boundary and overlay the overall data on top. data points on the top. So the SVM decision boundary, as you can see, they are with a different color indicating the different classes. And as you can see, the decision boundary is perfectly separating two classes and the support vector. The points closest to the boundaries are clearly visible, right? So to summarize, the support vector machine is a powerful tool for classification tasks. It works by finding the hyperplane that maximize the margin between the classes. We can use it for both linear and nonlinear classification, as we even saw how to implement and visualize the SVM using Python. So remember, the SVM is very versatile, and with kernel, you can apply it to complex and nonlinear data as well. So I hope this video helped you to understand the SVM in details. Thank you.